So let's talk adding fractions. The big thing to remember when you're adding fractions is you need to be adding fractions that are same denominator fractions, because the denominator is what we count by. So if we look at this situation, 5/8 plus 1/8, we're counting in eighths. And you can see up in the corner we've got a little bar that is broken into eighths. So when we talk about 5/8, we're talking about 1/8, 2/8, 3/8, 4/8, 5/8. What we add to that has to somehow be in eighths if we want it to make sense to us. So if I'm going to add one more eighth, we're good to go. Now if I tried to add 1/5 there, I'm not sure how that would have worked out, because what I'm counting in right now is eighths. So the good news is, as you can tell from the little bar here, we can just count these up. 1, 2, 3, 4, 5, 6. And how many? Well, we have a sum of 6/8. One thing we want to keep in mind, though, is it's always best if we can simplify or reduce fractions so that we show them in the simplest terms possible. In this case, I see 6/8, and I think to myself, okay, is there a number I can divide 6 and 8 by that will help me simplify those terms and make this a little easier to visualize? And the answer is yeah. In this case, these are both even numbers, so I can divide by 2. And 6 divided by 2 is 3, 8 divided by 2 is 4, and that leaves me with a simplified sum of 3/4. That's about as simple as it's going to get in terms of adding. Sometimes we're going to see two fractions that have the same denominator, and we're going to add them up. Oh, 5/6 plus 6/6. Well, 5 plus 6 is 11. And in this case, I'm counting in eighths, so it's 11/8. Here we get into a little bit of a sticky situation because our sum is a fraction greater than 1. In the math world, when we communicate in fractions, we don't usually leave fractions greater than 1. What we do is we try to convert them or change them so we can see the whole number part and the fraction part. We call that a mixed number. Well, how do we do that? Well, we need to take out what whole number portion there may be. In this case, if I have 11/8, I can take 8/8 out of that, because 8/8 would equal 1 whole, and that's going to leave me with 3 more eighths. That would be the fraction part of the number. So 8, 9, 10, 11, there we go. And how's that going to look as a mixed number? Well, this 8/8 is 1 whole plus 3/8. That's going to give me 1 3/8. Really quickly, if you wanted to see what that looked like by using traditional division, what we'd do is we'd make the numerator the dividend and the denominator the divisor, and we'd figure out, okay, how many 8s are there in 11? Well, there's 1 8 in 11, and if we take that out, we have 3 out of 8 left over. So we end up same, no matter which way we look at it. The important thing to remember is, if the fraction is a fraction greater than 1, almost always you're going to want to convert it into a mixed number or a whole number equivalent. That's adding fractions with the same denominator. What does it look like when we want to add fractions with different denominators? Well, that is a different kettle of fish, I guess you could say. So let's say I have 2/3, and I want to add 1/5 to that. Well, if you know how to compare these two fractions by creating equivalent fractions, then you're going to have a pretty easy time here. Again, because our denominators are different, we're not going to have an easy time putting thirds and fifths together. We could try and draw that out, but we'd probably end up in a big mess. So instead, we're going to try and create equivalent fractions. And those equivalent fractions, to be able to add them, are going to have the same denominator. Well, how do I know a denominator that I could use for an equivalent fraction for thirds or for fifths? Well, I need to think of a common multiple. So in my head or on my paper, I might start listing out the multiples of 3 and then the multiples of 5 until I find a multiple that they both share. In this case, 15. We can use 15 because we can create or we can discover a mathematical rule that will help us create equivalent fractions. In the case of 1/5, if we multiply that by 3, we have 15ths. Whatever you do to the denominator with fractions, you're typically going to do to the numerator. And so if I multiply by 3 again, now I've got 3/15 that is equivalent to 1/5. Now when I'm talking about 2/3, well, 3 times 5 will get me to 15, which means that I'm going to want a numerator 5 times greater than 2. And 2/3 will equal 10/15. Now it's a matter of adding 10/15 and 3/15. 10 plus 3 is 13, and we're counting in 15ths at this point, so we're going to keep it 15ths. The good news for us is here, there's no reason for us to simplify. In fact, we can't simplify this number. 13/15 is the simplest terms that we're going to be able to get for the sum. Remember, finding the equivalent fractions involves getting that common multiple and then uncovering the mathematical rule that you can use to create an equivalent fraction with that. Good luck, fraction finders.